Hi, how are you guys? We're back to Calculus 2 classes. Our class today is a little hard, not that hard, but with more practice will be simple and easy. All what you need to follow the rules. Before I start today, I prepare something for you. Just remember to know our class today is techniques of what? Last time we did substitution only. Today we're going to do trigonometric what? What's we doing?
Trigonometric substitution.
Which, class 5, which is mean using the trig function in our integration, right? Helping us to find the integration in easier way, right, Ismail? Good? Then using the integral function to the trigonometric function to help us find our integration. Let us start. Don't forget to subscribe if you like it. Okay, let us back to our board. Okay. Then we said techniques of integration. Our class is trigonometric substitution. Good. Trigonometric what? Substitution. Okay. Look, Ismail, there's a rule we have to follow. Look to the first rule. If you have this in the integral form, don't forget to put the timer, please.
It's on here.
Just in case.
Yeah.
How many minutes we have there?
2 minutes.
Then 23. Look, Ismail. If I have this form in my integration, square root of a squared minus x squared. You can remember this form when x squared comes negative, right? Your substitution will be x equal a over b sine theta. Good? All the time. I'm going to give you examples now, okay? Now dx equal a over b, and the derivative of sine is cosine. Is this clear? Then if I have this form, quickly my substitution will be x equal a over b, any number with x squared sine theta, dx a over b cosine theta. My associated triangle, that's the most important stuff. Most of the teacher, for me in my solving a problem, when I solve a problem, I like to have my triangle ready. Look here, since sine theta equal, if you cross multiply here, guys, look here, I need my students here to see sine theta equal b tan x, bx, right, over a, right? I'm right? Mm-hmm. And since you know the sine is opposite over what? Hypotenuse. Then you draw a quick triangle, and the theta will be here, and the opposite is bx, right? Mm-hmm. And the hypotenuse is what? A. Then this guy, okay, look here, let me give you this trick. The missing side always the original what? Form. Always. Good? Let us take example. Before I take the example, I'm going to give you 1 minute. Look to the what? Here. What? Look. The integration, my substitution. dx a over b cosine theta, sine theta bx over a, sine theta bx over a, right? Good? Mm-hmm. Okay. Let us take what? Example. Okay. Let us take example, and Example, first example. Integration okay. Good. Now look. So look here. What we have here. The x squared is negative, right? Right? Then which substitution I'm going to use? Sine, right? What's A?
Is one.
A is 1 and B is what? Both of them 1, right? Then x, my substitution is what? X equal only 1 over 1 sine what? Theta. That good? Now, dx equal what? Cosine what? Theta d theta. That's simple, right? Let me have my triangle ready before my substitution. This, I'm going to back to this one here. My triangle, let me have my triangle ready. Theta. Good? And sine theta from this. Sine theta equal what is my x over what? X over what? 1. Then sine opposite as we said. And 1 here. And I told you the trick is this always has to be this one. Good. Why I need this you will see now. Let us back to our integration now. We have everything on the side here. Integration 1 over 1 minus what x? Sine square theta, right? And dx is what? Cosine theta d theta. Good? Now, the things you need to remember. The first thing I need you to remember. Here I'm going to write it. 1 minus sine square theta equal what?
Cosine theta squared.
Yes. 1 minus cosine square theta equal what?
Sine squared theta.
Sine square theta. Good job. Okay. Let us go to our integration. 1 over. I'm going to take my time for you. 1 minus sine square is what?
Cosine.
Square theta. And here what? Cosine theta. Right? And this you can finish it to be integration of a square root of cosine square is what? Cosine theta, right? Tan cosine theta. This cancel with this and d theta. This is my equal integration of d theta. What integration of d theta is mine? It's only what?
Theta.
Plus c. What theta equal?
Theta.
Now you have to simplify in terms of x, right? Go back here, right?
This is going to be arc sine.
You see this guy and this guy?
It's going to be arc sine of x.
Yes. We have to write it in two forms. Theta equal sine inverse of x, or if you want, some books they call it arc sine x. Then my final answer, arc sine x. Okay. This is the first example. It's clear? Let us go harder. Go a little what? A little what? Harder. Then the first example was easy example, direct example with a and b equal both of them to 1. The second example. From 0 to pi over 2 Okay, x squared square root of 9 minus x squared dx. Okay, now I will need my student to help me. What I have, master? I have negative, I circle it quickly. I circled which one?
Negative x.
Negative x squared, which is mean which trig substitution I'm gonna use?
Sine.
Sine, right? Then what my substitution? Go ahead. Go ahead.
X equals.
What's a? If you want to see
A is equal to.
3, right?
Yeah.
A 3 because we have 9 here. 3 squared is 9, right?
B is 1.
B is 1 because we have no number here, right? 1. Then x equal a over b, right?
Yeah.
Which is 3 sine theta. Then dx equal 3 cosine theta or d theta, right? dx. Okay, good. What my triangle now, Ismail? My triangle has to be here, right?
Yeah.
Here my triangle. X sine theta equal x over what? 3. X over 3. Now draw the triangle. Now we need this, right? And this we need at the end, right?
Yeah.
This, I'm going to draw my triangle here. Triangle. I'm going to have it ready, right? Theta. Go ahead. Theta.
So
Go ahead.
it'll be X.
X where?
Right where your fingers.
Uh-huh.
And 3.
And here.
And then it's gonna be.
This, it should be this here. 9 minus what?
X squared.
X squared. Now I'm ready here with all my substitution, with all my steps. I have to be ready. I have to finish. Okay. Now, let us do our substitution. Okay. Now, let us go to this integration. Use now integration. I will not use 0 and pi over 2. I'm going to leave it to the end, right? I'm going to leave that my limits to the end.
Okay.
And I'm going to take x equal what now?
3.
Which is going to be 3 sine.
3 sine.
3
Theta.
sine, which is, I'm going to do it 2 steps. Okay, no problem. Square root of what? Right? Right?
Yeah. 9 minus.
Go ahead.
This.
9 minus
Sine.
9, right?
Yeah.
X what? X is what now? Sine square theta, right?
3 sine theta.
My with 3, 9, okay?
Oh, okay. I see what you did.
D theta. Now, what we did, the x is 3 sine theta, right? And the 9 is the 9. And because x equal 3 equals 3 sine theta, 9 sine square theta, right?
Yeah.
Now integration, d theta, integration, 9 sine square theta. And you can take the 9 out, right? And 1 minus sine square what? Theta, right?
Yeah.
D theta, right? Right?
Yeah.
Now integration, 9 sine square theta. And the 9, this becomes what? 3. 1 minus sine square.
Is cosine.
I'm going to do it 2 steps. Cosine what?
square theta.
Okay, cosine square theta, in case for some students,
And
now,
then
integration,
integration of,
9, 27, right?
yeah, 27.
I'm gonna take all the 27,
We can put it outside of the.
yes,
interval.
which is better for us. 27, right? Sine square theta, here d theta, and cosine theta, right?
Yeah.
Cosine theta d theta. I meant to, now, what we have to do, how are we gonna solve this guy? How are we gonna solve the last guy, right? How are we gonna solve the other man? Think about it, how are we gonna solve the last guy? At dx, we have, hold on, we forget something? We forget something, I think, right?
Don't you have to put the,
dx equals 3 cosine theta, right?
yeah,
Okay. Here, right? We have to back to this one, good, right? Because dx equal what?
3 cosine d theta.
Yes, dx, you see when we are organized, dx equal what? 3 what?
3 cosine theta.
3
Cosine theta.
d theta, right?
Yeah.
3 cosine theta d theta. Then dx, that's what we forgot to put, the dx, right? The dx equal 3 cosine theta d theta, right? Now, and here, 3 cosine theta d theta. Now, at the last step, when you multiply, look here, when you have square root of cosine squared is cosine theta, and 3 times 3, this is going to be 81, right?
Yeah.
This is going to be what? 81. Which is 9, and the 3, and the 3. And this is going to be cosine squared theta d theta. Cosine squared theta what?
D theta.
D theta. Okay.
Wouldn't that be 1?
No, that's plus.
Yeah, that's
That's
plus.
plus. If this one is going to be what? Plus. Okay, I will give it to you as, right? Okay, cosine squared theta, sine squared theta is, if you remember some rules, as a law of Trigg's function you have to know. I'm going to put the trig for this one in the top. It's a law of Trigg function here. Here, we have sine theta, cosine theta equal what, Ismail? 2 sine theta equal cosine 2 what?
Yeah.
D theta. Now, what we have now, we need only this guy, right?
Yeah.
We need only this guy. Let me just move my board a little up. Okay. Sine theta. I'm sorry. Sine theta. Cosine theta equals sine 2 theta over what? 2. You square both sides to get which one,
That.
right? Good?
So it's going to be sine 2 squared theta over 4.
Which is sine
Square
square 2 theta or 4. Okay, we are not done. Also, this is the first identity you have to remember, right? And there's another identity you have to remember, which is what? Ismail, go ahead. Which is sine square theta itself. It's half minus half cosine what? 2 theta. Good? You see? Sine square theta. I need you just to remember. I'm gonna give you all this at BDM, okay? Sine square theta equal what? Half minus half cosine what?
2 theta.
2 theta. But how many thetas do we have here?
2.
2. If you put this here 2, multiply this by 2, this has to be multiplied by what?
2.
Then sine, let me use different color. Then sine square, sine square 2 theta equal half minus half cosine what? 4 theta. Then all this guy here, you see this guy, we have it here. Let me back to my page here. All this, a little bit. Just to let you see everything together. Okay, that's good. Okay. You can see this now, right? This and this. Can you zoom please for them? If you can. You see the cosine square theta here? Sine square theta, cosine square theta, it's equal to what? Right? Sine theta, cosine theta equal sine 2 theta over 2, right? And when you have a square here, square, sine square 2 theta, and sine square theta equal half cosine 2 theta, then sine square 2 theta equal half cosine 4 theta. Sine square 2 theta over 4. Then all, right? And this is, we said what we need now here, this guy equal, okay, which is equal sine here. Sine theta equal this guy, sine square 2 theta over 4. Then I'm going to do it step by step. Then this guy equal integration of what? Sine, we have 81, and we have the 4 here, right? I'm going to take the 4 what here, 81 over 4, 81 over 4, the 4 comes from here, sine square 2 theta, which is equal half d theta, which is the last step. All this equal half, this integration, half integration 81 over 4 half minus half cosine 4 theta, d theta. Good? And I meant to have all the board next to you to see everything together. You can see that? Clear? Now this one, 81 over 4. What integration of half, mister? We're doing in terms of theta. Half what?
Half theta.
Minus integration of cosine 4 theta is what?
Sine.
Sine
4 theta.
over what? Over 4.
Over 4.
4. The derivative of the angle. Okay? Derivative of what?
The angle.
The angle. Now let us back to our old problem now, right? We can change the limit here Theta is pi over 2, right? Plus c, what the time? We have time?
25 minutes.
Plus c, plus c, and different integration. Thank you guys, and have a nice day.